In today's video, I'm going to quickly go over how to factor trinomials. Before we begin, you do have to know that factoring is just finding the terms that are multiplied together to get an expression. What that looks like is something like this. Here we have like a baby example. Factors of 20 are just, well, what are the two numbers that you multiply to get 20? So 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. So these are what we call factors. In an algebraic sense, here, it's kind of like the box method, but in reverse. So about a week ago, we learned how to multiply two binomials, and our answers always looked like this. But factoring is the opposite. It's where we begin with something like this, and we calculate what two binomials were multiplied in order to get it. So I'm going to jump right in. I do strongly believe that in order to get really good at factoring, you have to see lots of examples and practice. So to begin, we will start with number 1. We have to know that when you have a trinomial, it came about because you multiplied two binomials. So I am going to immediately draw my two empty binomials. What's nice about today's examples is the beginning term is just x squared. So the only two things that you can multiply together to get x squared are x times x. So that will always go in the front of our binomials when there's just an invisible one there. So that is what's nice about these examples. You'll always have your variables in the front. But now we have to start thinking, and we have to do this process where we find factors of 15 that add to give you a positive 8. So this is what I'll do. I'm going to make a list of all the factors of 15. To find factors, I like to use this little calculator strategy where we take our number, 15, we divide it by x, and we get a table, Control T. And this gives you a list of all of the factors. Now in factoring, we only really care about the whole numbers, so I'm going to find each group. Here I have 1 and 15, so that means 1 times 15 is a factor. I have 3 times 5, which means 3 times 5 is a factor of 15. And as I keep going, now I just have 5 times 3. But I'm actually not going to write that down because 5 times 3 is the same as 3 times 5. So I'm done with the calculator. Now I have to figure out which numbers can I add to get positive 8. So we're going to use the signs in our problem to tell us what to do. Now, to add, I'm going to make a little column over here. I'm going to start checking what's 1 plus 15. Well, that's 16. That's not what I'm looking for. I'm looking for 8. Well, now what's 3 plus 5? Well, that's 8. And because those are the two numbers that gave me 8, that means those are the two numbers that go in my parentheses. Well, just notice that was a positive 3 and a positive 5 that we added together. So I'll put a plus 3 and a plus 5. That is the factored expression. Now I'll move on to number 2. I will always begin by setting up my two empty binomials, and then I'll check my leading term. Because there's only an invisible 1 there, I know that the only two things that can multiply together to give me n squared is n times n, which means this n goes here, that n goes there. Now I'm going to check this last term, 10, and I'm going to find the factors of 10. So I'll make my little list. I'll just do this in the calculator since it's a really nice trick to get all of them. Factoring can be such a headache if you don't get all the terms. So here I have 1 times 10. I have 2 times 5. And then I have 5 times 2, which is the same as 2 times 5. So I'm done. That tells me stop. I already have everything I need. Now I'm going to carefully look at this symbol. That says I need to add the factors until I find positive 7. So now I'm going to extend this column a little bit, and I'm going to add things until I find 7. Well, 1 plus 10 is 11, so that's not what I need. But 2 plus 5 is 7, which tells me 2 and 5 are the numbers necessary to multiply to the last term and to add to the middle. So that was a positive 2 and a positive 5. So I'll put a positive 2 here and a positive 5 here, and that is my answer. Now things get a little bit different with problem 3. But the process is the same. I always begin by setting up my two empty binomials. I check the first term. Because it's x squared, I know that the only two terms that can multiply to give me x squared are x times x. Now I am going to ask myself, what are the factors of 18? So I'm going to make a little chart over here. And to find the factors, I will do that same process of taking 18, dividing it by x, and getting a table. The calculator lists them out for me. So I have 1 times 18, 2 times 9, 3 times 6, and I'm going to skip the decimals. Now I see 6 times 3, which we already have, so I'm done with the calculator. But this is where things change up a little bit. I now have to figure out what factors subtract from each other to give me a positive 3. Now, this is a trick I learned. When I'm subtracting, I'm going to subtract from right to left. So I'm going to make a tab over this way. And I'm going to take this term minus the term to the left. So 18 minus 1 is 17. Well, that's not what I need. I need 3. Well, now 9 minus 2 is 7. That's also not what I need. But here we have 6 minus 3, which is 3. Well, that's what I need because that's what the middle term is. But notice, I just did positive 6 minus 3. So I'm going to put a minus 3 and a positive 6 in my parentheses. So the signs will determine if you subtract or add the factors. Now let's look at number 4. I begin by setting up my two empty binomials. I check that first term. Because it's only n squared, I know that n times n are the only things that can multiply to give me n squared. So that's what goes in my parentheses. And now I need to find the factors of 35. So making my little factor tree, I'll do it down here. 35. I want to find all of the numbers that go into 35. So 35 divided by x, get my table, and I see 1 and 35. I see 5 and 7. And then I see 7 and 5. But 7 and 5 I already have, so I'm going to stop. And now I need to check this symbol, because this symbol tells me that I need to subtract the terms until I find the ones that subtract to a positive 2. Well, when I subtract, I always go from the right term to the left term. And I'm going to put a little minus here so we knew we subtracted. And I'm going to subtract these. 35 minus 1 is 34, which is not what I need. But 7 minus 5 is a positive 2, which is what I need. Now I'm just going to ask myself what the signs were on these. Well, I said 7 minus 5, so I'm going to put a minus on the 5. and the 7 was positive, and that tells me what goes where. So I'll put -5 plus 7, and that is our answer. Just in case you're curious, you could have also done n plus 7 and n minus 5. These are the same answers. The order doesn't matter with multiplication. We just have to make sure that our symbols stay attached to the numbers as we put them in. Now we have number 5. I set up my 2 empty binomials. Here, I know the only factors are x times x, so that's what goes in the first place of my 2 binomials. And now I want to find all of the factors of 24. So making my chart, 24 divided by x, find my table. I see 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it, because 6 times 4 is just a repeat of 4 times 6. Now I need to look at this sign. This tells me I need to add these terms together until I get a negative 11. So when I add, I go from left to right and I add the terms together. Well, 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. And 4 plus 6 is 10. Well, I know that I need a negative 11, but so far I only have a positive 11. So this is a little rule with math. If I have two numbers that are positive and they multiply together to give me positive 24, that's fine. However, what if both of these terms were negative? What is negative 3 times negative 8? Are those factors of positive 24? Well, you can check by multiplying negative 3 times negative 8, and it is a positive 24. And if I add negative 3 plus negative 8, I get negative 11, which tells me that yes, I will be adding these numbers, however, they both need to be negative. Another shortcut that you can remember, it's a rule, is if you have a plus sign back here, then the signs in your parentheses will both be the same, and they'll both be whatever this one was. So if you remember that rule, you can instantly know that both of your signs will be the same and they'll both be negative. Or you can recall that sometimes the product of two negatives will give you a positive, so you have to remember to check that if you don't find the exact number that you need. Number 6 is very similar. So we'll set up our parentheses. I'll put n's in the front. And we're looking for factors of 24. Factors of 24 we actually already have from this guy. And we can write them down again. And this is telling us that we need to find the factors that add to give us a negative 10. So when we add, we go from left to right. This adds to 25, this adds to 14, this adds to 11, this adds to 10, but I need a negative 10. Well, the nice thing about negatives is when you multiply two negative numbers together, their product is still positive. And when I add two negative numbers together, their sum will also be negative. So this is just telling you that both of your numbers that you input here will have to be negative. So that is our lesson on factoring. We are going to be doing these problems for about a week, and then we'll introduce some that are a bit more challenging where the leading coefficient is not just 1. But please don't stress out. There's many different ways to do these. This was just one strategy. We'll learn many others in class.